if inverse sine of P equals 2 times inverse cosine of Q, show that P squared equals 4Q squared times 1 minus Q squared. Okay, so first we're going to let theta equal inverse cosine of Q. So we have, so starting with the inverse sine of P equals 2 inverse cosine of Q, that's inverse sine of P equals 2 theta, since inverse cosine Q is theta. And if we take the sine of both sides, we have P is equal to sine 2 theta. And we know that sine 2 theta is 2 sine theta cosine theta. So if we look at the right triangle here, we have theta equals inverse cosine of Q, means cosine theta is equal to Q. So we call this theta. And we can think of Q as Q over 1. Cosine is adjacent over hypotenuse, so this is adjacent, that's hypotenuse. Pythagorean theorem says this is the square root of 1 minus Q squared. Now we go down here. Sine theta is opposite over hypotenuse, that is the square root of 1 minus Q squared. Cosine theta is adjacent over hypotenuse, so that's Q. So I'll just put it over here. So what we have is P is equal to 2Q times the square root of 1 minus Q squared. If I square both sides, that is P squared equals 4Q squared, and the square root goes away, and we have 1 minus Q squared. And that is exactly what we wanted to prove.